Hey everyone, my name is Jordan Levin and I'm a developer at Sparkbox. In this video, we're going to talk about some advanced techniques that you can use in Git. So let's go ahead and get started. At Sparkbox, we love Git. It's our go-to version control system, and over the years of experience working with Git, we've developed and adopted some best practices and workflows that we think are beneficial for any organization using it. These are the things that we're going to cover today. We're going to start with how we use Git, rebasing, merging versus rebasing, and interactive rebasing. So this is the workflow we're all familiar with, right? We have a bunch of developers, and we use Git as a way to share our code with collaborators. We work on code to build a feature, make some commits when we have something working, and commit changes to the repo to allow our collaborators to pull down the changes. Then, of course, we also have some special handlers to deploy our code to build agents that handle building our application, deploying it, etc. Git is an awesome way to handle this type of collaboration and deployment, but it's capable of so much more than acting as just a mechanism for syncing up code between various machines. The way we use Git at Sparkbox concentrates on the collaboration between developers by using advanced techniques in Git to curate our commit history both during the PR process and when our code is merged into our main branch. So why is this history important? Well, your repository history is an untapped trove of context and evolution. So let's take a deeper dive into what that means. Now, who's ever seen a commit history in the main branch of a repository that looks like this? Does anyone think that the information here is truly helpful? These merge commits tell me nothing about what's going on or what these commits actually do. What are these about? Work in progress commits? A test commit? Two commits dedicated to the same thing? It looks like there are multiple commits about the htaccess file, even though both commits are related to the same effort. And absolutely positively not helpful commit messages that don't really tell me what this is for. Are these new features? Are they refactors, bug fixes? Who would do this? It was me. This was the way I used to make commits on my own projects years ago. These are some real commit histories on a project that I built while I was in college. But I've since learned that the power of maintaining a useful commit history in my projects that represents the evolution of a codebase makes it easier for developers to onboard themselves to projects. Now let's take a look at another real commit history of a project. No merge commits to be seen. Instead, all of these commits have been rebased, more on that later, before being merged, meaning that all we're left with is the commit that describes the idea behind the commit. And remember those test and work in progress commits? No more unnecessary commits that add noise to the history. In fact, by including commits that are organized by an idea and not including superfluous commits, each commit can be checked out individually without breaking the application, a really helpful feature when debugging. And with a compressed history, developers can easily onboard themselves to the history of the code base. Two commits dedicated to the same thing? Not here. Instead, you can see that each individual commit has been squashed before merging into our production branch, meaning that although the PR may have contained multiple commits, they have been squashed before being merged. Also, more on that later. And lastly, the use of commit types via the conventional commit spec tells us what kind of commit this is, which makes automated versioning a breeze. Getting your repository to the place where you are organizing your commit history into sensible timelines that showcases the evolution of your codebase makes it easier for new developers to grok and elevates your Git history into a useful but curated ledger of changes. But why does this matter? Well, consider this. Let's say you're on a project, you go on vacation for a week, and you come back to the project. You want to see what's new with the codebase, what new features have been added, what bug fixes have been made, just to make sure that you're all synced up. Which one of these commit histories would you find more useful? Beyond that, this style combines commits in a PR that are centered around a single idea and represents that as a single commit. Another benefit is that it makes Git blaming a whole lot easier. In this example, you can see that when blaming this file to check out changes, I'm subjected to only looking at two commits. That's because this file has undergone changes twice, once when it was created and once with a bug fix. What you're not seeing is that the bug fixes were originally 4 separate commits that were squashed into one before it was merged into main. Otherwise, if all 4 commits were merged into main as is, it would add additional noise in the form of 3 additional commits. Squashing them into one makes it easier to view the changes to a file in a Git blame because I don't have to look at changes from the same effort fractured amongst multiple commits. Additionally, centering a single commit around a single idea allows developers to explore the commit with all relevant files without having to bounce between individual commits. The added context given in the commit body tells us why these changes were made to give developers more historical context as to why the changes were made and what the thought process was. At Sparkbox, these are our guiding principles. It's that main should always be in a deployable state. Going even further, each individual commit represented in main should also be deployable. This makes it easier for us to roll back or revert a commit that introduces breaking changes. Additionally, we believe that the commit history should act as a resource that shows the evolution of your code and not just relegate the commit history as a ledger of chronological changes. So with all of that in mind, this might be you right now. You might be saying, I'm sold. How can I start curating the commit history in my branches before they get merged into our main production branch? Get Rebase to the rescue. So let's talk about rebasing. What is rebasing? Well, rebasing is simply updating the basis for your current branch. You are updating the base of the branch. So when someone asks you to rebase on main, they're asking you to take your changes and base them or rebase them on what's currently on a different branch. Imagine we have a repo. So we have main shown here in orange. And now we have a great new feature branch in blue. But at the same time, we have a new commit in main that was merged in. We make another change to our feature branch. And now we have one commit ahead and one commit behind. If I want to get the changes from main back into my feature branch, I'm going to have to rebase my branch on main. So this is the act of rebasing. What you're doing is, in effect, rewinding the head of your branch to the branch you're rebasing on, checking out their changes, and now adding your commits back in one at a time. Now this is the happy path. This is the path where no merge conflicts come in. Now let me see if I can read everyone's mind. What you're asking is, okay, if you're reapplying your changes on main one by one, where are you resolving merge conflicts? Merge conflicts are unavoidable if there are irreconcilable changes between main and your feature branch. This would happen whether you're merging main into your feature branch and resolving conflicts with a merge commit, or you're resolving them in each individual commit while rebasing. When rebasing, we resolve our merge conflicts in each commit where they exist before continuing the rebase. This means that our commit history won't have any pesky merge commits because they're resolved before the rebase is completed. If we have a merge conflict in a file, we'll resolve it during the rebase and rewind our own history to erase the fact that the merge conflict ever happened. Because fundamentally, merge conflicts aren't useful or interesting to highlight in the history of the repository. So, what does that look like? Well, we resolve the conflicts in our existing commits. This means that we're rewinding our own history to reflect how we would have made our changes had we branched off of the latest version of main versus an outdated version of main. We resolve the conflicts in our own commit and continue the rebase and go along our merry way. But let's take a closer look at how we're resolving merge conflicts while rebasing. This is the same diagram as before, but let's pretend that these commits represent text changes in a file. Our first commit in main is simply hello. Then we branch off and we add some punctuation. But while we were working, someone added world to our text, and then we updated our greeting. Well, we're going to hit a merge conflict here. And that's because our changes are now on an alternative timeline than they were before. Git is telling us that the current text is hello world, but our new text is hello. And we need to help Git out to help resolve the conflict by asking, how would we have made these changes had hello world already been in main? Well, all we did in this commit is add an exclamation mark, so if the text had been hello world instead of hello, we would have simply said hello world with an exclamation mark. So we'll update that and then we'll move on. Rebasing rewrites history. It's the Git equivalent of time traveling into the past and making a change. When you rebase on main, you are effectively modifying history to make it appear that the changes in your current branch were made on top of the latest version of main, even though they weren't. It's creating a linear history based on the latest version of main. This is the question you should be asking yourself when resolving merge conflicts. How would have I approached this had the circumstances been different to begin with? So let's consider this example. If your morning routine was to first wake up, second, look outside of the weather, and in this case it's sunny, and third, to get dressed, you might grab a t-shirt. But what if the circumstances were different? What if you saw snow instead of the sun? Would that fundamentally change the next step? Probably not. You'd probably just grab a sweater instead of a t-shirt. But the step here of getting dressed is fundamentally unchanged. These two scenarios, seeing sun versus seeing snow, are in essence divergent timelines. To better explain this, I want to bring in a special guest speaker.
Prior to this point in time, somewhere in the past, the timeline skewed into this tangent, creating an alternate 1985. Alternate to you, me, and Einstein, but reality for everyone else.
Thinking about how Back to the Future represents time is really helpful when resolving merge conflicts. For those who haven't seen the cinematic masterpiece that is the Back to the Future trilogy, this is the timeline. Our hero Marty McFly time travels from 1985 back to 1955 in a DeLorean. However, while in 1955, Marty accidentally modifies the past. He is now in a divergent timeline because the changes in 1955 have ripple effects that go all the way to 1985. At the beginning of the movie, he and Doc Brown are at Twin Pines Mall where they test out the time machine. Marty travels back to 1955, but in the past, Twin Pines Mall was Twin Pines Ranch, meaning that the developers of the mall simply named the mall after the ranch. While in 1955, Marty accidentally crashes through one of the two pine trees at the ranch, which, since it was done in the past, of course has an impact on the future. Which is why, when he arrives back at the mall in 1985 at the end of the movie, the name of the mall is changed from Twin Pines Mall to simply Lone Pine Mall. Because the ranch being renamed doesn't fundamentally affect the creation of the mall. Instead, the mall would have just been named something different. By the end of the movie, Marty is in a 1985 that is on a divergent timeline because of changes in the past. Does this sound familiar? This is the timeline for the name of the mall in Git. We have Twin Pines Ranch. We want to build a mall, so we name it Twin Pines Mall. But while we checked out our branch, Twin Pines Ranch turned into Lone Pine Ranch. Well, we'll go ahead and rebase on the main timeline and move the tip of our current branch, which means that the change is fundamentally the same, but the name of the mall is different because the basis of our changes is different. And this is a similar timeline we had in our previous example. So, how do I use this new magic sorcery? Well, just check out your feature branch and run git rebase with the name of the branch you want to base your current branch on. If you hit a merge conflict, don't panic. Just resolve the conflict, stage the file, and continue with git rebase continue. Now, if you do panic, that's okay too. Just run git rebase abort, and the rebase process will cancel out, and your branch will be reset to what it was before the rebase was started. Notably, whenever you change history in Git, the SHA of your commits will change. And this change in the SHAs will require you to use the force with lease option when pushing to the remote. The force with lease option is a non-destructive force, unlike the regular force. A force with lease tells Git that you are rewriting history, but that it should only accept your changes if all changes on the remote are represented in your push. For example, if you attempt a force with lease push, but right before you did another developer made a commit on your branch, your push would be rejected, since Git will say, hey, I can't force push this branch because there's work on the remote that isn't in your local branch. Plain forces, however, will absolutely write over other people's work, even if it's not represented in your branch. So remember, force with lease is non-destructive. Force is destructive. Related to pushing is polling. If anyone modifies the commit history on the remote repository, you won't be able to pull like normal. Instead, running git pull, you just run git pull rebase. This is telling Git that the SHAs in the remote are different than what you have locally. Executing a git pull rebase will pull the rebase changes locally while accommodating the updated commit history you have on your machine. Now notably, This is why we never modify the commit history directly in main, because it would require all developers to do a git pull rebase when pulling down the latest changes, which is not intuitive. So with all of these powers, this might be you right now. You might be saying, I can't believe I can have such a clean and clear commit history by using git rebase to incorporate changes from the main production branch into my branch. But why is this preferred over merge commits? Well, let's get started by talking about rebasing versus merging. Now, in this specific case, we are comparing how we get changes from main back into our feature branch. We have two ways of doing it: merging main back into our feature branch, or rebasing our current branch on main. Okay, so Sparkboxers are very fun and friendly folks, but we do have some opinions, particularly on the merging strategy. And these opinions are that we don't like regular merging, especially ones that resolve in merge commits. And there's a reason why. It's that it adds unnecessary noise to the commit history via merge commits. Plus, if you look at the history of the main branch in Git, it's really not pretty. So let's talk about the difference between rebasing your branch on main versus merging main into your branch. So same repo as before. We have main here in orange, and now we have a great new feature branch in blue, but at the same time, we have a new commit in main that was merged in, and we make another change to our feature branch. So what happens if I merge this into main? It's still an accurate timeline that reflects the time when the commits are made. But the process of merging the feature branch into main can cause conflicts in main, creating a merge commit. From a historical perspective, the ordering of feature branch commits relative to main, like we see here, makes the evolution of the feature branch less clear. Let's reset. This time, we rebase the feature branch on main and execute a merge into main using the FF only option. Voila! We can see our feature branch commits are merged into main. And since it was rebased before merging, all merge conflicts were resolved in the feature branch and the history is clean and clear. Let's see how that looks in reality. You can see this O character. It represents a single linear commit history. Every commit was made directly on top of the previous commit. This makes it easy to read through the commit history. On the other hand, look at this subway map. Commits are nonlinear. What's showing up in this commit history is that branches were made off of made and then merged in via merge commit, adding these pesky merge commits and creating a nonlinear commit history. So this is causing two areas of pain. One is that we get a merge commit, and one is that we have a nonlinear commit history. This is a quote pulled directly from the Git documentation. The difference between merging versus rebasing has no impact on the end result. However, using rebasing makes it clearer to those looking through the history of our codebase of the evolution of our application in a way that is decoupled from the actual chronology of changes. So, pros and cons. Both approaches effectively do the same thing. It brings in changes into the main branch back into your feature branch that's outdated, like what happens if someone else's PR is merged into main before yours is. Let's look at merge commits. If you have merge conflicts, then that's going to manifest itself via a merge commit if you do a traditional merge. However, if you do a rebase merge, then the merge commits are resolved in your commit that has the merge conflict. Linear commit history? Not the case with merging, where you'll get that subway map. Lastly, an important one, support for accounting for changes in approach. Since rebasing puts all of your changes on top of changes that are already in the main production branch, you get the chance to change your approach based on changes that were merged into main after you branched off. As an example, let's say you add to a file in a single commit, but that file was moved by somebody else's PR, and that change was merged into main. This is a change in approach that we should account for. With merging, we would have to add a merge commit. With rebasing though, we first rebase our changes on main, get the new location for the file, and then resolve our conflicts in a commit where we added to the now relocated file. From a historical perspective, there's no evidence of the merge conflict. Instead, it'll look like all we did was added to a now relocated file. And now, this might be you. You might say, okay, I'm absolutely sold. I'm ready to use rebasing instead of merging to get changes from main into my feature branch. But we've only talked about how to get changes from main into my branch. How do I get a clean commit history when I merge my feature branch into main? Well, this is the last trick. Interactive rebasing. Rebasing allows us to modify history by incorporating changes from another branch. Interactive rebasing goes a step further and allows us to modify commit history by adding, deleting, reordering, editing, or rewording our commits in our history. It's time travel. It allows us to go back in time to edit the history of our feature branch. Well, why is this useful? Remember this commit history? Let's pretend this was the commit history for a feature branch and I was getting ready for a reviewer. Well, if I want to organize the commits in a way that helps onboard my reviewer to the PR, this commit history needs some work. I might want to reorder certain commits to optimize readability and guide my reviewer through my thought process. Curating commits for PRs is a whole different topic, so we'll leave it there for right now and focus on the how instead of the why. Interactive rebasing is pretty simple. It uses the rebase command but with an I flag. In this example, I'm running git rebase -i against main. This means that my current branch will be rebased on main, and then I'll get the ability to edit all the commits in my current branch that are not represented in main. Alternatively, if you don't want to compare your branch to the main branch, or you're not ready to rebase on main yet, you can specify head tilde following a number with the number of commits to show from your current branch in descending order. Here, I'm telling Git that I want to enter interactive rebase mode and I want to see the last 10 commits of my current branch. When you run this, you'll be presented in the editor of your choice, like Vim, Notepad++, or VS Code, with a list of commits in descending order. This is the home of interactive rebasing and where you'll be running all of your commands. In this spot, you can do some pretty amazing things. You can reorganize the commits simply by changing the order. Now you also get these really cool commands. This allows you to tell Git what you want to change about your history, like editing a previous commit, rewording it, or even deleting it entirely. From here, if I wanted to reword the top commits message, I would just change the command from pick to reword, or R for short. If I wanted to combine the second commit with the first commit, I would just change the command here from pick to squash, or S for short. And after I close this file, Git will go through the process of executing my commands and will alert me of any merge conflicts, if any come up, as it's going through each commit. Now, these are the commands that you'll be using when you use interactive rebasing. Although there are a lot more, these are the most common ones that you'll come across. Now, keep in mind that while using interactive rebasing, like rebasing, you are rewriting history. You might recall that I mentioned this before. See? I told you I showed you this before. Again, rebasing rewrites history. It is the Git equivalent of time travel, and you go into the past to make a change, and then you return back to the future. This means that you can encounter merge conflicts when using interactive rebasing within your own branch. To resolve issues, you stay calm and remember this mantra. This is the question you should be asking yourself. It's nearly identical to the question that we ask ourselves when rebasing on main. However, in this case, we're asking about how we would have approached making changes within a single branch instead of two. So what does that look like in practice? Well, call back to this slide, but a slight variation. What if you woke up, got dressed, then looked outside, and had to get dressed again because you dressed for sunny weather and it was snowing? Well, this seems to be like a bad routine. Before I get dressed, I'll look outside. This means that had I looked outside before, I would have never had to pick out a t-shirt and I would just pick out a sweater to begin with. This means that I never would have had to redress. Now, this is the same approach you would take when you're resolving merge conflicts with rebasing or using interactive rebasing. So with all these powers, this might be you right now. You might be saying, I can't believe how powerful interactive rebasing is. You're right, and I'm sure you are eager to try it out. Looking to take interactive rebasing for a spin? Check out Advanced Techniques in Git, the repo. This repo has a series of challenges that will cover the techniques and strategies that we went over today. This repository has different challenges that will cover real-world scenarios. This will include rebasing, reordering history with interactive rebasing, editing your commits with interactive rebasing, and cherry-picking commits. To get started, go ahead and clone or fork the repo with this URL. Now, all of this is done locally, so you won't need to be pushing changes back up to the remote. Before we go, some last words of advice. Combining two commits is always easier than splitting a single commit apart. If you're unsure whether changes should be represented in one commit or two, use two. You can always combine them later. As you're rebasing, it's possible that you complete and then realize that you've made a mistake. Depending on the severity, you might elect to revert your branch to what it was before you started the rebase. The Git reference log, or ref log, is your friend. It's a ledger of all of your changes and all of your commands. After running this command, you'll see a log of all of the commands that you've run in the past. This command is a non-destructive command, so feel free to run in any repo to view the log. As you read through each line, you'll see that these aren't just commits, but they're actually Git commands that have been run most recently. You'll be greeted by a screen that looks similar to this. Now, what's important is these SHAs. These SHAs and pointers, represented by head at, can be used to reset your current branch to the state that it was at any one of these points. This means that you can use the Git reset option to reset your branch to a time before the rebase. Now, this isn't something that you should be doing frequently, but it is available as an option if you have no other choice. So these are the 4 topics we covered today. We talked about how Sparkbox uses Git and our approach to using it as more than just a deployment mechanism. We talked about rebasing and how you can use it to change the basis for your branch and rewrite history. We went over the benefits of rebase merging versus regular merging and how rebase merging provides a clear, linear commit history free of merge commits. And lastly, we talked about how you can supercharge your Git workflow process by using interactive rebasing to travel back in time and change your branch's commit history. And that concludes our venture into Git and some of the advanced techniques that you can use with it. Thanks for watching, and be sure to check out sparkbox.com/foundry for more advice and insights from discovery to launch and everything in between.